Hi guys, welcome to the project exercise solution now. I hope you have tried your best to answer all those questions and many of you or maybe all of you have already done the project by yourself. Anyhow, let's move on and try to get the results what are given in this exercise. So the first thing is the libraries are already imported and the data set is already loaded. We need to run these cells first so that we will have the data in iris. We can check the keys, simply run this cell. So the next step is create a data frame and output the head of the data. Use feature names as column. So we now have iris.keys and feature names are actually the column names and data is our data. What we can do, we can create a data frame df is equal to pd dot data frame, and we can pass in iris data as a data and columns iris, which is features name, and let's see how it looks like. So we have to display the head of the data. So it looks like we got the same output. Now he's asking for import standard scalar and create an instance for standard scalar. We know we have standard scalar in pre-processing. Import dot standard scalar and let's create an instance of standard scalar. As there is no error, so we believe that we have imported and created a standard scalar object. So the next step is fit the standard scalar to the features in your data. So we have 4 features. Let's fit the standard scalar object to the features. That is again a simple thing. Scalar dot call a fit on scalar and pass in the data frame. And yes, we got some output. So it means the scalar is working and we have fitted the scalar object on our data frame. So the next thing is he's asking for please transform the data to the scaled data. So we have to scale the data now. We can simply say df scaled and then using scalar objects we can transform the data frame. So there's no output, no error. So we believe the transformation actually worked. The next step is principal component analysis. He's asking for import PCA and create its instance. What should we do if we are interested in only first 2 components? Let's import the PCA first from Scikit-learn, and we know it is in decomposition class import PCA. So now let's create its instance PCA. So while creating its instance, we have to pass how many components we want. So he's asking for 2 components. So this is what we needed to do. In the next step, he's asking for fit the object to the scaled data. Now we have the scaled data in df scaled and we need to fit the PCA object on the scaled data. So PCA we call the fit on df scaled. So we got some kind of output. So it looks like our code is working here. So now we got the fitted object on the scaled data. So the next step he's asking for, let's transform the data to its first 2 principal components. So let's call it PC12 for first and second component, call transform on PCA using scaled data. So it looks like it is working actually because there's no error. So the next step is PC1, 2. So we have two components, principal component 1 and principal component 2 in PC1, 2, which is NumPy array. He's asking for to create a data frame so that it looks better. I believe an easy task for you. Let's call it df underscore PCA, call data frame from pandas, pass in the data PC1, 2, and columns we can pass in the list PC1 and PC2. And let's check the head of the data frame, df underscore PCA dot head. Look like it's working, so we got the same answer here. So we have principal component 1 and principal component 2 in two columns. So the next he's asking, please recreate the plot below. This is actually a scatter plot, and we can use PLT like matplotlib. Let's define the figure actually first. Say fig size equal to 10.8. We can call a scatter plot on PLT, pass in the data x as df, which is our first principal component, df PCA PC1, y is df PCA PC2, and now c is our target value that we can get from the original data set. I think we are in the wrong cell. Let's copy this one because we want the output. So yeah, it looks like it is working. We got the similar plot, but the color is not same. So it looks like they have used set one color here actually. So let's pass in c map equal to set one and see. It looks same now. The only thing is we have to give the x and y labels here, which is first principal component PC1 and second principal component PC2. We can set the label using plt dot x label, which is one PC1, and we can copy this one and we can say y label, which is principal component 2. We have created the same plot here. Let's move on to the next one. How to get components, create a data frame and output its head. So we know we can call components underscore on PCA on our fitted object and get the components. If we run this cell, we got these components. He's asking to create a data frame. So let's create a data frame. We create a data frame df underscore PCA underscore comp and call pd dot data frame and pass in the data, which is our PCA dot components, and then we need columns that we can get from the original data set, which is actually feature names. So let's show the head of our data here. So we got the same result. We have recreated the same results here. So the next is, please recreate the plot below. So we have to recreate this heat map. We can use SNS and call heat map from SNS, pass in the data frame and see how it looks like. Something similar, but the size is very different and the color scheme is not the same. So it looks like the C map here is rainbow. So we got the same color scheme, but the size of the figure is not same. So we can do this thing as well. PLT, we can set the figure size equal to, I believe this one is 12.6. So we got the same plot here now. We have the sepal length, sepal width, petal width along x-axis, along the horizontal side, and we have 0 and 1, the principal component 1 and principal component 2 along the vertical axis. So the next step is actually the machine learning using these principal components. So we are using here support vector machines on principal components. First we have to separate target and features. So he's asking separate features and target classes and do the train test split. Let's do this thing. X is actually our features, which is scaled features. So x equal to df underscore pca. Y is our target values. This is what we can get from the original data frame, and then run these cells. I think we need to insert another column here, another cell here for train test split. So from Scikit-learn dot, now we know it is under model selection, import train test split. So we need to insert another cell here. Sorry about it. Let's do shift tab here and copy the code. Here it is. So we usually do the test size 30 and leave the random state as 42. This is wrong here. We need target values here. Yes, now it's working. The next is he's asking for import SVC and create its instance. Let's do this thing. We know in Scikit-learn under SVM we have SVC. Let's create its instance a model SVC. So we are done with this one actually. Now he's asking for to train your model. So let's call fit here on model and pass in our train data. So we got the same results actually. We have trained our model on the training data set. So the next step is he's asking for predictions. Let's do predictions now. We know the test data set and let's call predictions on the model. Pred equal to call model dot predict and pass in the test. So we got the predictions from our model in Pred. Next is print classification report and confusion matrix. So we have to import classification report and confusion matrix here. So we know from Scikit-learn dot, it is in matrices, import classification report, and you can always use tab for autocomplete. And then let's print classification report and pass in our test and pred. Let's copy this one here and paste this here. We have confusion matrix, and let's see how the results look like. Yes, we got the same results actually. So we have the confusion matrix here, and we have the precision and recall F1 score and support here. Excellent work, guys. I hope you enjoyed learning PCA. You have realized how powerful this statistical tool is for the higher dimensional data. Although we have implemented in the project on a dataset with only 4 features, but still those 4 features are actually converted into 2 principal components. We use 2 principal components to apply classification algorithm that works perfectly. So the results above could be improved with the grid search to find out the best values for C and gamma, and we know we have learned this grid search in the support vector machines lecture. This was only a test project for practice, so we did not do the grid search because focus was to learn principal component analysis, not support vector machines. So good luck and see you in the next lecture.